All right, so we have a request to do number 5 on page 142. So I'm going to go ahead and walk you through that. We are asked to find, the directions I didn't write down, I just wrote down the problem, but the directions say to find the equation for the line tangent to the curve y equals 4x minus 3x squared at the point 2, negative 4. So in order to do that, we know that to find the derivative, we have to use our formula, the limit as h goes to 0 of f of a plus h minus f of a all over h. And in this case, we actually know our a. Our a happens to be 2. So I'm going to go ahead and when I do substitution, when I substitute all this in, I'm going to go ahead and use that I know that we are doing this at the point 2. We're not making a generic formula, we're making a specific formula in this case. So I'm going to do f of 2 plus h minus f of 2 all over h. All right, so we have the limit as h goes to 0, and our original equation is 4 times x. Well, instead of x, I'm going to write my 2 plus h, and then the original equation is still minus 3x squared. So again, instead of writing x squared, I'm going to write 2 plus h squared. And then that's minus f of 2. Well, we already know f of 2. We know f of 2 because it was given to us right here in the point. So I don't even have to calculate that. I just know that I'm going to subtract negative 4 off. And now I need to do some expanding and some simplifying. So I have the limit as h goes to 0. And this would be 8 plus 4h if I distribute that 4. Minus our 3 times, and I'm going to go ahead and expand that one. We will have 4 plus 4h plus h squared plus 4 all over h. And hopefully here we'll be able to start canceling some stuff out. So I have 8 plus 4h minus 12 minus 12h minus 3h squared plus 4, again still all over h. So when I look at this, the 12, or let's see, this 8 and this 4 have a sum of 12, and I have this negative 12. So all of those are going to reduce, and we know from our experience that that's exactly what we need. We want to get rid of everything that doesn't have an h. And now everything left has an h with it. So we have all of these terms that all have an h. So I'm going to go ahead and factor out an h. And I'm going to take out an h, so we have, when we're all done with that, we have the limit as h goes to 0. And when I take out an h, I have 4 minus 12 minus 3h all over h. The h's will reduce. If I plug in 0 now at this point, I get 4 minus 12 or negative 8. Okay, so we're not done. All we have found at this point is the slope of our equation at the point 2, negative 4. All right, we just discovered that the derivative or slope at the point 2, negative 4 for this function is negative 8. So we are going to use the point slope form for an equation. So it's y minus y equals m times x minus x in order to write our linear equation for this. So basically, I just need to plug in the y value from the point, which is negative 4, the slope, which is negative 8, and then I'm going to plug in my x value, which is 2. Now, since we're asked, actually in this problem we weren't asked to graph it, we're going to go ahead and graph it. So if we're asked to graph it, it makes the most sense to go ahead and put in y equals form, so, or our slope intercept. So if I do that, I'm going to end up with negative 8x plus 16 when I distribute the negative 8. And then this plus 4 that turned into, I'm going to subtract off. So I'll get y equals negative 8x plus 12. So we're saying that this linear equation right here at the point 2, negative 4 will be tangent to this curve up here. And to show you what that looks like, I'm going to go to the next slide and I'm going to go ahead and show you the graph. As you can see from this picture, the red graph is our y equals 4x minus 3x squared, and the blue graph is our tangent line. And you'll notice that there's a point right here at the point 2, negative 4, because that's the point that we're finding the tangent line to. And It's just hitting it in that point. So we have confirmed that this indeed is the tangent line to the curve at the point 2, -4.